Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over orbital diagrams and the principles and rules on how to fill them up. So in a previous video we talked about orbitals and how there's different levels of energies for orbitals. So the few things that we need to know about orbitals is that they are described by their energy level, their energy sublevel. They are described by their shape, and they are described by their orientation in space, as well as the number of electrons in there, or the spin of the electrons, which is describing more of the electron than the orbital itself. But these are things that we need to keep in mind. So in this video, what I'm going to show you how to do is how to fill in an orbital diagram using the rules. So I'll give you one example. So let's get into this. So here is an orbital diagram. And so what you'll notice is we have this broken up into different levels. And so the first number that you see here is the energy level of the orbital. And then the letters here we talked about last time in a video, that the letters here represent the shapes of the orbitals. And you can see that they're broken up into sublevels. So we have levels and sublevels. So we have level number one. Level number one only has one sublevel, and that sublevel is the S sublevel. And each line here represents an orbital in that sublevel. Okay, so you can see here in this energy level here, number one, that is only one sublevel, and so it's the S sublevel. In energy level number two, notice we have two sublevels here. So we have the S sublevel and we have the P sublevel. And you'll notice that we have three lines here. Those lines represent the three P orbitals that are at that sublevel. And so we talked about in a different video about the orientation of the orbitals. So again, they're oriented again along the different axes, the x-axis, y, and z-axis. And so this would be, maybe this is the px orbital, this is the py orbital, and maybe this is the pz orbital. So we can label those here if you like. So that would maybe be x, this is the y, and that's the z. So three different orbitals, p orbitals, at the p sublevel at energy level number two. And so remember, the energy levels are those n numbers, n equals 1, n equals 2, and so on. So here we have n equals 1. Here's we have the energy level number 2 with 2 sublevels. And then we have energy level number 3, and this is where the d sublevels come in. This is where your d orbitals are. And you'll notice that there are three sublevels. Notice the energy level number 3, and we have three sublevels. We have the S, the P, and the D. And again, notice here we have 5 lines. That's the 5 d orbitals, and the different orientations that they have in space. And then, of course, we have the energy level number 4. We have 4 S, P, D, and then there's an F sublevel that I didn't draw in this diagram, because I just want to go over, just for the purposes of this video. I cut it off there, and then you go to 5S, 5P, and 6, and so this is your orbital diagram. And again, like I said, I cut it off short, but it goes further. The other thing I want to point out is, again, I said before, is that the energy of the sublevels increases going up. So the higher the number, the higher the energy. And so remember that the electrons closer to the nucleus, if the nucleus is down here, if I was to draw a nucleus, this is the nucleus of the atom. So that nucleus, the electrons that are closest to the nucleus are going to have the lowest energy. As you get farther up in energy, you're going to get farther away from the nucleus. So the farther away you are from the nucleus, the more energy. So here we have energy increasing going up. Okay, so here's our orbital diagram. So how do the electrons go into the orbital diagram? So what rules do we follow? And so over here I have a few rules. I have two principles and a rule that we're going to follow. And so let's go over that right now. So first is the Aufbau principle. The Aufbau principle basically says an electron occupies the lowest energy orbital that it can first. So it's going to reach the lowest energy. So it wants to go as low as possible if there's space. So basically, electrons are going to fill from the bottom up. So think of this as a building and the elevator's broken. There's no elevator, and you have to go up the stairs, right? So are you going to go all the way up 7, 6, 10 flights of stairs? No. So you're going to want to be in the lowest floor of your building. So think of the energy levels as floors of your building. Maybe that analogy works for you. So electrons don't want to go all the way up. They want to be lowest to the ground. They want to be down here if there's room. So if all of the space down here is filled, then they have no choice but to go to the next floor. And if that's filled, they have no choice but to go to the next floor. But they want to have the lowest energy possible. So when you start putting electrons into your atom, into the different energy levels, you're going to start low and work your way up. Okay, so that's the Aufbau principle. The second principle is what is called the Pauli exclusion principle. And in a nutshell, that basically says that each orbital can only hold a maximum of 2 electrons. And they must have different spins. So we talked about how electron is either a spin up or to spin down. So those 2 electrons must be oppositely spin and they in the same orbital. So if you have 2 electrons in the same orbital, they have to have opposite spins, and you can't fit any more electrons into that orbital. And so that's only 2 electrons in an orbital. And then third we have is Hund's rule. And so Hund's rule basically says that if you have orbitals that are of the same energy level, like for example, here we have 3p orbitals, and these are the 3p orbitals. So 3p orbitals, they all have the same energy. These 3p orbitals have the same energy. You could see the d orbitals here. The d orbitals have the same energy, so all 5 of these d orbitals have the same energy. So when you have orbitals that are of the same energy, then the electrons are going to occupy the orbitals one at a time before you pair them up. So you don't pair up electrons into an orbital until you've actually filled one each first. So think about having your own room. Everyone wants to have their own room first. You don't really want to share a room with someone. Maybe you do, but for this analogy, you don't really want to share a room. You have your own private room. So people are going to fill in and take the single rooms first before you start bunking up with someone in your same room or having a roommate, right? So you prefer to have a single room until we don't have enough. We have too many people, and so we need to bunk people up into rooms. So that's an analogy to help you remember Hund's rule. So Hund's rule says you got energy, you got orbitals of the same energy, you put electrons singly in each one at a time here, and then if you have other electrons that need to go into an orbital, then you start pairing them up. But again, remember that they have to be opposite spin. The other thing you want to be aware of with Hund's rule is that all have the same spin. So when you put them into the orbitals here, they all have to have the same spin. Okay. So those are the two principles and the rule for orbital diagrams, and how do we fill those in. So you want to think of an orbital diagram as basically um, an address of where the electrons are. Where are they placed in the orbital diagram, right? So where we place those electrons will place them in the orbital diagram according to these rules. All right, so let's go over an example. And this might be very unclear, but going over an example will be helpful in making this clear. So let's go over what would be in a good example. Let's go through boron. I'm sorry, not bromine. Bromine is number 35 on the periodic table. So that means that the bromine atom has 35 electrons because we're assuming a neutral atom. So the bromine has atomic number 35. Therefore, it has 35 protons, and we're going to assume that it has enough electrons to balance out the charge. So 35 electrons. Where do those electrons go? Where are they housed in the electron? This is the structure, this is the electron structure of the atom. So when you have electrons in your atom, the electrons are going into orbitals. Remember, orbitals are those spaces where you can have a probability of finding the electron somewhere within that space. And depending on what orbital you're in, you have a different space or different probability space that you are occupying. So how do we fill these electrons in? We have 35 electrons. So again, this is bromine, right? So let's see how we fill these in. So again, we're gonna follow the outbound principle. That means that electrons want to be in the lowest energy possible, lowest energy orbitals first, and then they're gonna work our way up. So when we put our electrons in, the first electrons are gonna go into low energy until those are occupied, and then when this is occupied, we put them in the next lowest energy, and then the next lowest energy, and then next. So these are building up. You can see where the energy is increasing up. So this is lowest energy. This is the next lowest. This is next, and then follow here, and then this one, and then this one is next, and then this one over here is next, and then followed by that one, and so on. So we're following the order of the energy level. So let's start with the first electrons. So the first electrons are going to be put into here. When we put them into the orbital diagram, we draw arrows to represent spin. So the first arrow spin up, and the second arrow spin down. So those are two electrons. One has a spin up, one has spin down. Notice that they have opposite spins. That is following the Pauli exclusion principle. So the Pauli exclusion principle says that we can only have a maximum of two electrons, and those electrons have to be opposite spins. So here's our one orbital in the 1s sublevel. So we have an s orbital here. So we're putting those two electrons there. The next one is another s orbital, and now it's at the higher energy level, which is energy level number 2. That's going to have two electrons. So now we're going to put a spin up electron there and a spin down electron there. So here now we have two electrons there. So we've used up 4 of electrons, but we got 35 total. We got 31 more electrons to put in. Next, we're going to put electrons in this one. This is the next energy level, the next lowest energy sublevel, right? We have a sublevel S and we have a sublevel P. So now this is the next one. So we have 3 p orbitals, px, py, pz, that are the same energy. So we need to follow Hund's rule here. So Hund's rule says if there are more than one orbital with the same energy, we need to put the electrons in each one singly first before we pair them up. And they have to have the same spin. So we are going to put 3 electrons in here. So we first do this. We have 1 electron, spin up. We next fill this one up, spin up, and then this one, spin up, and we keep going. So this is how many electrons? This is 7 electrons. Again, we have 35 to fill in, so we got to keep going. So now the next electrons are going to be paired up. So remember, we fill them in one at a time singly, and then we pair them up if we have more. But we have more. So then this one's going to be spin down, this one's going to be spin down, and that one's going to be spin down. So again, following Hund's rule, we filled one in one at a time, same spin, and then we paired them up with opposite spins. So now we have, what is this? We have 10 electrons. We have 25 more to go. So we keep filling them in. So we're following the Aufbau principle. We're adding electrons to the lowest energy levels, building ourselves up until we run out of electrons. So we've got 10, we've got 25 more to go. So the next energy level is the 3s. So we're going to put 2 electrons here, spin up for that one, spin down. Again, we only have one orbital at the s sublevel here. That's one orbital. Here we have the sublevel p sublevel at the 3rd energy level. And again, we have 3 equal energy p orbitals, the px, py, pz. So again, we're going to follow Hund's rule, and we're going to put them in one at a time, same spin. So that's going to be 1, 2, 3. So those 3 electrons go there. We got more electrons, so we're going to have to fill them up. So we're going to pair that one up, spin down, pair that one up, spin down, pair that one up, spin down. And so now we have 18 electrons used up. We've got more. So we got to keep filling up. The next energy level is here. So we're going to fill this up. And so this is the 4s. So again, s, this sublevel only has one s orbital. So we're going to fill that up with 2 electrons, spin up, spin down. And so now we have 20 electrons. We have 15 more to go. So let's keep going. So now where do we go? So we have the 4s. What's the next highest energy level? Right here. So this is the next energy level. So we're going to fill this one in. But notice that all 5 of them are the same energy. So we're going to have to follow Hund's rule here. So we fill them in one at a time. So spin up, that's 1, spin up 2, spin up 3, spin up 4, spin up 5, and now we're going to pair them up. Spin down, spin down, spin down, spin down, and spin down. So that's 10 electrons in there. So we had 20. Now we put 10, that's 30. We have 5 more electrons because bromine is number 35. Number 35 on the periodic table. So we have 30, now we need to fill in 5 more electrons. What's the next one? It's right here. So that's the next energy level. So those electrons have to go here. Again, Hund's rule, we're going spin up, spin up, spin up. Okay, that's 3 electrons. We need 2 more. Those 2 have to go here, and we're going to pair up 2 of them. So that's spin down and spin down. And so now we have all the electrons put into the orbital diagram for bromine. And so this is how the electrons are structured in bromine. We have electrons in the 1s, the 2s, the 2p orbitals, the 3s, the 3p, 4s, 3d, and 4p. Now there's a couple of things I want to point out here. We said that there could be 2 electrons in each orbital. So each line, remember, is an orbital. And so the 1s is the lowest. So each s sublevel can hold a maximum of 2 electrons because there's only one orbital in that sublevel, right? So 1s only has the one sublevel, the 1s. The energy level number 2 has two sublevels. This sublevel only has one orbital, like one line. So that only has two electrons. But this sublevel, the p sublevel here, has three p orbitals. Each orbital can hold a maximum of two electrons. So that means that this sublevel, the p sublevel, holds a maximum of 6 because there's three orbitals in the sublevel, and each orbital holds two electrons. So that's a maximum of 6. And it's the same for all of these p sublevels. This one can hold a maximum of 6. This one can hold a maximum of 6. This one can hold a maximum of 6. And then when we get to the D sublevel, so this 3D sublevel has 1, 2, 3, 4, 5 orbitals, 5D orbitals. And so since all 5D orbitals can hold a maximum of 2 electrons, that means the total number of electrons is 10. Same thing for this one as well. So this has 5D orbitals in this sublevel, the 4D sublevel. And so this can also hold a maximum of 10. And I didn't draw the F sublevel. It's somewhere over there. But if I was to, we saw before that the number of orbitals in the F sublevel is 7. There's 7 F orbitals. Each orbital holds a maximum of 2 electrons. So that means that an F sublevel with 7 orbitals can hold a maximum of 14. And that's going to be very important later on when we talk about the periodic table in a future video. I hope this was helpful. So these are the rules. This is how you use the rules to fill in your orbital diagram depending on how many electrons you have. So different atoms have different number of electrons, and so they're going to fill in the table a little bit differently, but they all follow the same two principles and the same rule. So these are always followed. I hope you enjoyed this video. I hope this was insightful. If you like this video, please like the button, smash that like button. Please hit the notification bell for being notified of other videos I put out. Please subscribe to my channel. Put a comment in the comment section. Let me know what you think. If you have any questions, please ask. Thanks for joining me, and have a great day.